on it and extract and bring it back.
That is freaking
I liked how they made
unreal.
it. I like the whole, like, how they made it, and I like when they put the light on.
I'm gonna try to make that.
I know, I'm just
That'd be really fast project.
I'll make it.
One thing I don't know what it is. We need to try like ID.
Oh, goodness.
All right.
That was sounds interesting.
Would it be really cool?
On the asteroid would be really cold. Mm-hmm. Well, I guess the date there, you know, if you're facing the sun, it might be a little warmer, and if you're away from the sun, it might be a little. But there's no atmosphere, so it'd be pretty cool.
When I used to think of asteroids, I just thought of fire. But it's not.
Because they're going so fast.
Oh, yeah. They're really cold out there. And like, so you see that dawn. I think I will.
Thank you.
I'm going to go to this website, though. I might have my dates mixed up, but. Yeah, I'm laughing. Okay. Must be okay. October 19th, that's coming up. There is a comet that's going to have close grays to Mars. And what this article says is they weren't sure if this comet was going to crash into Mars, but now they're pretty sure that the rovers are going to and get some good pictures. So, and the thing about naming comets, you're like, really? How did they come up with? It's called spring. What is it? Sighting spring. Like, really? It's kind of like whoever sees the comet first, usually they name it after their last name. Like there's a Linear, the guy was Linear. And if Linear finds more than one, you can add numbers on that or associate the date with the comet. Okay? So yeah, this talks about close calls and a wake-up call for the Earth. Okay, so I threw this one up on, doesn't this look like a picture of the one in Russia, remember? Where they had all those camcorders on their vehicles? Yeah. Okay, so asteroids, I don't know what blank you need to fill in. I feel like that video talked a lot about asteroids. And the reason we can only see asteroids is if the light is reflecting off of them. And then if that's the case, actually we'll see them move in the nighttime sky. So asteroids, they're kind of found in a couple different locations. One is the main belt asteroids, like after Mars, before Jupiter sort of thing. Okay. In the belt asteroids, there is a large belt asteroid called Sirius, which actually is the same classification as Pluto now. Pluto's a dwarf planet, Sirius is a dwarf planet. Ding, ding, ding. So it got promoted when Pluto got demoted. Okay. But what this says, kind of unlike what the video I thought kind of emphasized, is that if you were to take the asteroid belt and kind of take all those little crumblies and put them together, they still wouldn't make a planet. So things need to have a lot of mass to make them spherical. And so a lot of potato-looking things. And notice the asteroids have their craters and everything. And this is adorable. This right here, this orbits this. Okay, so they're both asteroids, but like there's a satellite orbiting.
It's like so tiny.
I know, it's
Oh,
adorable.
I noticed.
So they actually do call it a moon though?
Yeah, they call it a moon or satellite. I think that is so cool. Well, it's not working. Okay. So if somebody says something about asteroids, they're probably talking about most asteroids are belt asteroids. The two other types of asteroids you're going to need to know are also here. So there are three types of asteroids here. That first little paragraph, belt asteroids. This one, Trojan asteroids. This one are Apollo asteroids. So three types of asteroids. The Trojan asteroids, I have a slide to kind of show show you, they're kind of like gnats ahead of Jupiter and behind Jupiter as Jupiter orbits the sun. Apollo asteroids, those are the ones that are going to get us. So this is kind of talking about, let's see, the way you look at this is the sun is over here. This is like a part of the track of stuff orbiting the sun, okay? So here we see Earth track, here we see Mars track, the sun's over here. Here we see the stuff in the belt, the asteroid belt, and over here we see Jupiter. So you can kind of see within the asteroid belt there are kind of sweet segment spots. Okay. But this kind of says that Jupiter kind of nudges things up, and so it can't form a planet. All the stuff can't form a planet there. So remember, I wasn't going to spend a whole lot of time on these because the movie did it for us. So asteroid belt asteroids, asteroids in the asteroid belt, Trojan asteroids, and Apollo asteroids. So with all this talk of asteroids, okay, asteroids, and the movie said it, and I'm gonna have a slide to emphasize it too. If you pick up a space rock, what you are picking up is a meteorite. A space rock is a meteorite. When it's in outer space, it's an asteroid or a meteoroid. Okay, get the oid thing? Asteroid, meteoroid, space rock. I mean, in outer space. If it's on Earth, you pick it up as meteorite. So I kind of did these in the order which they happen. I did them backwards in the order with which they happen. A meteorite is what you pick up. Okay. A meteor doesn't last very long. This meteor, like a meteor shower, a meteor is just that streak of light as the rocks falling through Earth's atmosphere. Okay, so the meteor doesn't last very long. And a meteoroid is the thing when it's in outer space.
Have you watched?
Watched what?
It's a movie, and they have like there's stuff in outer space.
In outer space? Oh, is it
No, Zero.
is that where they, the one where they're floating
How many
and
movies are stuck in outer space though?
Gravity? Is it Gravity?
No, it's like a really old one. Zathura.
Is it a series?
No, it's like a I don't like a kids
Apollo
movie, but
11.
it's not. It's like a kids movie, kind of. It's got Bella in it. That was in Twilight, but it was a long time
It's
ago.
like the
Before she
second
was, like,
version
big
of
actress.
Jumanji, and then Zathura.
They they play a game and they go
Oh.
into space. But when they go out of space, it's like all this stuff.
now I know what
Find the
you're talking
name and tell me, because I'm curious.
The name is Zathura.
Athura?
Zathura.
It's like they play this
Zithra?
game, and then they
Oh, like
get,
Jumanji kind of? Because Jumanji's creepy.
and then they go to outer space. But it's funny because like this chapter and then like the last chapter, like different things you say are in that movie.
Oh, okay.
Like they like pull a card and they all say stuff. It's really good.
What's a good movie?
It's my favorite movie.
The guy in the movie, in the documentary we watched, held up different types of meteorites, okay, stuff that survive Earth's, the fall to Earth's atmosphere. And in general, there are the primitive ones and the processed ones. Now, I'm not going to give you a meteorite and ask you to identify which is which, but primitive ones are like the primordial, haven't been messed with since basically our solar system started to be a solar system. The processed ones, something's happened to them between the early on time of our solar system. So these are examples of primitive meteorites. And these are examples of processed meteorites. Have you guys ever heard the term? Because aren't we all about, I'd love to find a meteorite. They used to have a series where these guys went out with like little metal detectors, and maybe it's fancier than that, but a little wand to try to find space rocks. Meteorite men. Have you ever heard the term meteor wrong? Get it? You hope it's a meteorite, but it's a meteorite. I know. So the other thing, and this doesn't necessarily have to do with this slide, but I like what the video said, and they showed a picture of like snow and the black space rock on top of the snow, because like, that's easier to find. Did you also hear where like stuff, like debris and stuff, adds mass to the earth that was like 100,000 tons or something a day? 100 tons, I don't know. It was a lot of mass a day. It's kind of a subtle thing.
Like when they show that stuff coming down.
Yeah.
I didn't even realize that went on.
No. Crazy. Oh, and my thought was, yeah, and half of it ends up in my house. That dust, you know? Yep. Oh, but what this says is, and it has to do with kind of tracking it back to the moon or tracking it back to Mars. But we do know that when stuff's been banged around, including Mars and the moon early on, some of its stuff has actually ended up as like little rocks that made it through the Earth's atmosphere. Isn't that cool? All right. So I like what she did with making a comet. Was that not cool? Yeah, this is a very pretty. All comets, they just have a different amount of this, and the color is different for the different comets. So comets need coldness to form. Okay, and most comets, like unless they're close enough to the sun, most comets just float around, and you don't see the pretty gases coming off of them. So, I'm not sure which comet this is, but this is trying to point out some common features of any comet. Now, sometimes some features can be big, some features can be puny, depending upon the comet. So comets tend to have, well, I guess it's coming up, but comets can often be called a dirty snowball, okay? Because in there is literally rock and ices and, you know, just like she made it. The middle part we call the nucleus, okay, and it's shrouded in gas. Okay, so a little bit about the anatomy of a comet. They didn't cover this on that video, but so next to the nucleus, when it gets close enough to the sun, actually the rock, the comet itself, the gases start to fizz, okay? And then kind of around the nucleus, we call the coma. There are two tails, excuse me. There is a dust tail and a plasma tail. Okay. So the dust tail is, let's see, which one's straight? Which one is that? Plasma tail looks like it's straight and the dust tail arches. So the tails, though, one of the things, and every once in a while, I think it's significant, I'll put on a test. Do you remember when we talked about solar wind? We said that, and actually that little animation we looked at when our solar system formed, said when the sun turned on and created solar wind, kind of cleared out the little fog and stuff. Well, the solar wind is blowing all the time, and so actually it's the solar wind that drives the tail. So regardless of the direction, because you see the direction of this comet coming down and around, the direction of the comet, regardless of the direction that it's going, the tail is always going to be pointed away. It's not like a kite, you know, a kite, you're like, the kite, the tail always kind of moves away from where you're running and stuff. What's blowing this tail is the sun. Okay? So, do you see when it's running this way, the tail actually is going to run in front of it. Cool. We saw a little bit of this excerpted on the video, the landing on this comet, or it wasn't landing on this comet, they shot something at the comet. I think the comet was offended. Dude, I'm shooting something. Pretty cool. It was kind of disturbing. What I thought is basically you look at the impact, the dust flies up, and then it kind of just, it's kind of like it heals its wound or something. All right, meteor showers. One thing that the video didn't talk about. And I have a link to kind of show you meteor showers. But Meteor showers are caused by comets. And this is kind of showing you how they're caused by comets. So this ring right here is the orbit of a comet. Notice only kind of when the comet is near the sun does it start to kind of break up and give crumblies. This right here is the orbit of the Earth. When the orbit passes through comet debris, okay, it's stuff that the comet's long gone, the comet's doing its thing out there, but the comet left its debris. When the Earth pushes through that comet debris, then we have an extra dose of stuff falling through the Earth's atmosphere. Okay, that is a meteor shower. And, of course, we talked about, the Earth is orbiting the sun. You figure this is seasonal, right? Same time in our orbit about the sun are we going to hit that debris field. So that's why they have the Perseids in August, Earth passing through. And I have a little, I'm going to go to a website here, I think, that shows you what comet left the Perseid debris. Wasn't that nice then?
No, we haven't talked that much about the comets, but what was that years ago when that comet was going and those people killed themselves because of that? Was that one that was just, why did that stand out so much?
I'm not sure. I think it was a naked eye comet, wasn't it? Something you could see.
So.
Yeah. And the thing about, those people doing something religious to take their, take a pact. Oh, because they thought they were going to go.
Yeah, they thought they were going with that comet.
Comets historically have been, before we kind of turned more to science and all that, comets were just really locked into gloom and doom and superstition. So, a meteor shower is when the Earth is pushing through comet debris. Just happens to be that particular point in our orbit about the Earth. It was left by a comet who's not there right now. Okay. So, but in case I forget to mention it, okay, just wild meteors, okay. If you have dark skies, you should see one every 10 minutes. 1 meteor every 10 minutes with dark skies. No shower, just miscellaneous. Okay. The cool thing about meteor showers is they're all going to come from the same, what we call radiant. Okay, so the Perseids come from Perseus, the Leonids come from the constellation Leo, the Geminids come from the constellation Gemini. Okay. So here is, yes, these are the links I was going to show you. So you can get these, I think, in your textbook, but just a link to this year's meteor showers. The thing about if you're looking at a list of meteor showers, dates and such, you need to look at how many they're going to be per hour. Usually it's a ZH, some sort of hourly rate. And if it says 10 per hour, don't get up. If it says 100 per hour, yeah, go find some dark skies. The problem with meteor showers is if the moon's out and you're having those streaks, if the moon's too bright, you're not going to see it. So that's another. It's always something.
So how would you see it?
Yeah, if the moon is out, even with like a, crazy meteor shower, if the moon is out, you're not going to see it. People go, eh. Yeah. There are like little tricks, like you can kind of try to sneak in viewing when the moon, before the moon rises or after it sets. So just try to work around it. So the Orionids, October 21st. Actually, I might have seen a few of those miscellaneous. And the Leonids, November, Geminids, December.
Do they have times on that, or is it a hit or miss situation?
What I usually tell people is look at the internet, because they'll tell you when the best time is.
That'd be interesting.
Yeah. And it varies a little bit. But usually it's like between 2 a.m. and dawn. Yeah. But see these numbers right here? Wait, no, that's okay. I'll have to find a different table to kind of show you how many for each shower. But the other website This is funny. Now, I don't add to Wikipedia, but every once in a while, it seems like it's probably right. Here's a site that just talks about meteor showers. And down here at the bottom is that table that shows you the source comet. So, you know, I was talking about the Perseids. It came from Comet Swift-Tuttle. So, Halley's Comet left the Orionids. Every once in a while, it won't be a comet, it will be something else that left, like an asteroid, basically. It says minor planet, but. All right, so here we come, orbiting the sun, and we run into debris from a comet. And it's kind of like when you're driving and you get mesmerized by the snow. Okay, so
You like focus on that?
yeah,
It hurts my head, but I do it every time.
yeah, it's not a good thing. So comets, we kind of, I think the video did a pretty good job talking about I called it the Kuiper Belt, and I'm sure he's probably right. He called it the
Cuvier belt or something.
Cuvier, yeah, Cuvier Belt or something.
Well, I couldn't pronounce it anyway, so.
Kuiper Belt Oort cloud. And hopefully you kind of, and actually we talked in this test a little bit about the difference between comets in the Kuiper Belt or the Oort cloud.
So there's another cloud out farther than the Oort cloud, is that what they said? What did they call it? That has asteroids too, or did I not hear what she said right?
I think she said that the Oort cloud actually used to be closer to the sun, and now it's kind of fluffed out to where it is.
I think
Yeah.
but the Oort cloud's out.
Yes.
Yeah, I got that right on my list.
Kuiper Belt Oort cloud.
Is it hard as well? Okay. What? What'd you say?
I said, yeah, I got that one
Oort
right on
cloud
my
is the farthest
test.
one out. So there will be, on that test, there's a few ones that, I would take every test out of the fewer than were possible, because there are a few of them that I just know. We'll go over it next week. All right. So, Pluto, oh, you need this one?
Just one, got it.
So Pluto, I kind of feel like we've been talking about Pluto off and on. Pluto comes up again, we talk about the Kuiper Belt, right? Because Pluto really is more just like a Kuiper Belt object. We'll call it Kuiper, KBO, excuse me, Kuiper Belt. So this says that, and I can't remember I don't think this is a homework question, but this says that actually they aren't going to run into each other. Pluto is not going to run into the last gaseous planet, Neptune. So classifying Pluto now as a dwarf planet instead of a full-fledged planet, okay, it's just the route to go. He's kind of odd man out. We got 4 and 4, and then there's Pluto. He's more like a comet, and we've kind of talked a lot about that, I feel like. So, Eris. Oh, Eris! Okay, Eris is the object that grad student found and started the whole thing. Well, we found the 10th planet. So, no. He found another Kuiper Belt object, okay, which was even larger than Pluto beyond Pluto's orbit. So, kind of other icy bodies are kind of listed here. You kind of see things kind of drawn relative scale.
Do you think there'll ever be another planet discovered?
In orbit about our sun, another planet? I don't think so, but I don't know.
So Eris and Pluto are dwarf planets, and the other things are just, well, that's an asteroid, but like
No, actually,
Numia, and what are those? Are those also?
no, I think these are all, well, I don't know. There's Ceres and I think Ceres is a dwarf planet too. Vesta, I've taken. See, Ceres is large, Vesta is pretty large, but smaller than Ceres. And that's a dwarf planet.
Oh.
Yeah. So I think all these might be dwarf planets. Should check. I should check. So the Kuiper Belt begins kind of about Neptune, and you kind of see kind of things drawing a scale up here. So seeing Eris, that's pretty impressive. Seems like we kind of just rehashing things we've talked about. So in 06, that was actually when the folks that make such decisions about definitions came together. They had never defined a planet. You know what I mean? They just like, oh, planet, okay. But there was not a textbook definition. So they came up with 3 criteria to be a textbook definition. So Pluto has, is it 5 or 6 moons now? But Pluto, we knew for a long time it had a moon called Charon. And the cool thing about Pluto and Charon is almost as big as Pluto. And so there's a lot of wobble in Pluto's, because actually they both move, they orbit a common center of mass. Okay, so there's Pluto and Charon and Nix and Hydra. I'm going to take you out to a NASA site that kind of shows you so there's what, 3 there? Oops. And I'm not going to I don't think I am going to take you there again, but remember that Pluto is going to be honored by that spacecraft called New Horizons.
Next year, right?
Yeah, and I think it's bumped to summer. I think it's like July of 15. Okay, so here we go. There is Pluto, Charon, Hydra, Styx, Nix, and Kerberos. 1, 2, 3, 4, 5. Yeah. So there you go. They just keep finding them. Did you guys know, was this right? I think the guy who found Pluto, okay, not the guy who found Eris, but the guy who found Pluto, Tannenbaum, I want to say, beyond Neptune's orbit. He found Pluto, and his ashes, after he passed away, were on a spacecraft. Are they on New Horizons? I want to say okay. All right, so we could go to that website, and there's a countdown clock in Malcolm. This actually, remember the video or the documentary that talked about Jupiter? And the guy got real excited because he anticipated when a comet crashed into Jupiter that there would be this sort of plume coming up. Okay, that's what you're looking at there. The comet is called Shoemaker-Levy. There's 2 last names, Shoemaker-Levy 9. It must have been their 9th comet to find. Right. SL Shoemaker-Levy 9. This is kind of a close-up of, remember the Galilean moon Callisto? Orbits Jupiter, and this is kind of a crash landing of a comet interacting with the surface. And I think it did a pretty good job of this. I have a few slides that talk about, talk you through the whole dinosaur thing. The impact near the Yucatan Peninsula. I think these slides or your textbook takes a slightly different confirmation approach. It really focuses on the element iridium. So iridium is just an atom that has, it has 76 protons in its center. Remember the protons in the center of an atom say what sort of element it is. Okay, so iridium is not real common on Earth, but it tends to be common in space rocks. So basically what they have found is a layer of dust that has iridium in it that coincides with the demise of the dinosaurs. It's kind of a neat story because it's like a father-son that went out, geologist, biologist, I'm not sure. Okay, so this kind of talks you through how would an impact of a meteoroid, how would that wipe off have such a drastic effect? And it talks about the impact would throw up debris. Okay, the debris would block sunlight, and then of course without the sunlight you have problems with plants surviving, okay, and mass extinction ultimately. So the location of the impact is here, kind of the Yucatan Peninsula in Mexico, 65 million years ago. I liked, this slide reminds me of the video, I like that guy who has a little program that when people would ask, what would happen if this size of asteroid or this size of meteoroid, the only difference between a meteoroid and asteroid is size. Asteroids are larger, meteoroids are smaller. That's it. Oid thing, right? But I like it that he said that his little program says what will happen. Does this look familiar? What's that?
I'm gonna get that version. Oh, that was the version.
Thank you. So remember this on the video? The whole, yeah, I think they did a good job. The tree falls in the forest, no one's in it. It really makes a sound. Lots of trees falling. Not very funny. So I do have a link on here to kind of take you to NASA's site. Remember, NASA has been authorized, not authorized, but what is it when they say you have to? Congress says, NASA, you must be able to locate a certain size. And so what if they don't? So the whole thing about looking up at the skies and seeing those things coming, actually there is a public movement that's been going on for a while, trying to get scientists together and resources to strike out on their own to make it happen, because afraid that NASA's not really going to protect us from that danger. They're doing it for their kids. So this is that Tunguska event in 1908. So that's around kind of, let's see, when was World War I? Was it 11? I don't know. I think it was kind of when things were simmering and actually communication was kind of stunted. But Barringer Crater, Winslow, Arizona. So the marks are there. So this just kind of talks you through the smaller they are, this is how this works. The smaller they are, the higher the frequency they are. The larger they become, the less frequent they are. Okay. So, but again, I talk about, and I know it is not analogous at all, but with the floods we've had in the last, 30 years or so, really? 20 years. So sometimes I've shown this to students, this thing about Apophis. It's kind of a little clip there, but they're talking about Apophis. The size, very large. It probably won't get into us, but that one guy wants to put a transponder on it, which I'm okay with. They say that if there's an asteroid with your name on it, it could be problematic to try to blow it up. Because if you blow it up, you might just have lots of pieces coming at you. Okay, so to try to change its trajectory is probably where they want to go. Where did my... You're like, no, we need to go. And this is the one I was going to show you. We're going the wrong direction. So this is one that you don't want to show your kids. I like how they have the data organized here. NEO, I don't know if you can see that there, stands for Near Earth Objects. Okay, so Near Earth Objects. They could be asteroids, meteoroids, again, rocky, just differ by their sizes, or they could be comets. So let's see, close approaches, shall we? So it's a table of what is on the horizon. So today is the 9th. So the first table is what's already happened. Okay, so the 5th, 6th, 7th, 8th, 9th. Okay, and we're okay. So of course they name it, they say how close it is. Now this one ought to, the LD stands for how close it is relative to the distance from us to the moon. So about 2 LD means that it's about twice the distance from us to the moon, okay? And they give the estimated diameter. Let's see. But these are the ones coming up. So, yep. But you know it would be in the news if it was really bad, right? Okay. So what this says, and actually this in the next slide says that actually the gaseous moons, especially Jupiter, because it's the biggest, was great at kind of deflecting stuff that otherwise might have hit us. But also Jupiter will sometimes take something that's minding its own business and change its trajectory. So it comes to the inner solar system. Okay. So impacts, are they good or bad? I think maybe somebody was saying that. I don't know. Impacts can be both. Good and bad. Yeah.
I
So.
wouldn't wanna like mess with it and like have the world blow up, but I don't, like, it sounds stupid.
It's true. It's not too bad.
It's tricky, it's a tricky situation.
It is. It is. Is that the last slide?
Yeah.
Okay. Very good. And we're done for tonight then. And then, so chapter 9 will be due next week. So next week we'll go over your exam and then we'll do chapter 11. Okay? And when you print it out, it's already seen chapter 11 will say chapter 12. Guess what chapter 12 will say? Yeah. So just, I know you'll bear with me. Yeah, don't forget your 2 lab write-ups by next Friday. Midterms and all, right?
It's okay to email those to you, or do you want
Yeah.
to print them off and bring them into you tomorrow?
No, email is fine. See ya.
Good job.